Now we'll discuss the modern theory of trade or equivalent theorem. In neoclassical theory, we say that the difference in autarkic price, this is the basis of mutually beneficial trade between two countries. But equivalent theorem was an inquiry, what is the basic reason behind such kind of comparative advantage. So equivalent theorem has explained comparative advantage in terms of factor intensity and factor abundance. So first we will consider the assumptions of equivalent theorem. So it's a 2 cross 2 cross 2 model. That means two countries A and B, two commodities X and Y, two factors labor and capital. Now, second assumption is that the countries are subject to perfect competition. So perfect competition means in each commodity market there will be marginal cost pricing. So there will be no existence of supernormal profit. And the countries are, the markets are full employment. That means if you in a country you want to increase the production of X, you have to reduce the production of Y and vice versa. Just like the neoclassical theory. Next thing is the factors are perfectly mobile within domestic boundary. That means 5 factors can easily migrate from one sector to another in a country with equal efficiency. But they cannot migrate internationally. That means their factor prices will be same across the sectors. Even if there is change in difference in factor prices in two different sectors, the automatic mechanism will bring about equality once more. For example, if wage rate in sector X is more than wage rate in sector Y, what will happen? The workers will start to migrate from sector Y to sector X. So in sector X there will be excess supply of labor, wage rate will start to fall, and in sector Y there will be excess demand for labor and wage rate will start to rise. So this mechanism will be continued until and unless the wage rate is same across the sectors. Next thing is production function. So for a same commodity, production function will be same across the countries, but it will differ from one commodity to another. So here we see that production function of X is different from production function of Y, but production function of X will be same in country A and country B. Production function of Y will also be same in country A and country B. And this is very crucial assumption that commodities can be ranked unambiguously as per factor intensity. So even if there is a change in factor price ratio, factor intensity will not change. So they can be ranked. If we say commodity X is relatively labor intensive commodity, it will always remain relatively labor intensive commodity compared to commodity Y. So we cannot expect any kind of factor intensity reversal. And next is the standard assumption of production function, which is subject to constant returns to scale and constant elasticity of substitution. Next thing is cost trade will be free and costless. So in this case, equivalent proposition says, proposition of HO theorem. So if we consider relatively labor abundant country, it will have comparative advantage in relatively labor intensive good and vice versa. Now let us start with the definition of factor abundance. So here we will consider Ohlin's definition of factor abundance or price definition. Ohlin says country A will be called relatively labor abundant country if wage rental ratio in country A is less than wage rental ratio in country B. So this is called price definition of factor abundance or Ohlin's definition. So here we say A is relatively labor abundant. So automatically B is relatively capital abundant. Now let's define factor intensity. If we consider ALX by ALY, ALX by AKX, labor capital ratio in sector 1 is greater than labor capital ratio in sector Y. If labor capital ratio in sector A is greater than sector X is greater than labor capital ratio in sector Y, we can say X is relatively labor intensive and Y is relatively capital intensive. So from here we can write ALX into AKY greater than ALY into AKX, or ALX AKY minus ALY AKX is greater than 0. We give it equation number 1. It will be required later. So now, first we take a general form of wage rate and rental rate. So price of X as per competitive zero profit condition will be given as W into ALX plus R into AKX. So this is equation 2A. And similarly, price of Y is W into ALY plus R into AKY. So this is the cost of producing one unit will be exactly equal to the price of it. Average cost, cost to marginal cost equals to price. So if we do it, 2A is divided by 2B, we will get Px by Py equals to W into ALX plus R into AKX divided by ALY plus R into AKY. So here we will try to establish a relationship between Px by Py with W by R. So in right hand side we have to bring the component that W by R. So for that what we do, we will take R as common. So it will be W by R into ALX plus AKX. Similarly R into W by R ALY plus AKY. So R will be dismissed. Now we see Px by Py equals to W by R into ALX plus AKX W by R into Y plus AKY. So now we have to find out the relationship between Px by Py and W by R. So what we need to do? We have to differentiate equation 3. We have to differentiate 3 with respect to W by R. So left hand side will be dpx by py divided by dw by R equals to, we have to do the differentiation in u divided by v method. So that means it will be given as W by R into ALY plus AKY whole square. So first it will be W by R ALY plus AKY into, now we will differentiate this with respect to W by R. So here we will get ALX plus W by R into dALX plus dAKX minus W by R into ALY plus AKY whole square. Now here will be W by R ALX plus AKX into ALY. Again, now we will differentiate this with respect to W by R. So ALY plus W by R dALY plus dAKY. So now we have to look at these two components. We have to reduce the volume, reduce the components. So now we will consider the least cost factor combination for production of X, if we consider for commodity X. So least cost factor combination for commodity X will require marginal rate of technical substitution between labor and capital in sector X will be exactly equal to the wage rental ratio. So this is the slope of isoquant and this is the slope of isocost line. So from here what we can write, that MRTS LK in sector X will be represented by dAKX by dALX. So that equals to minus W by R. Or we can say dAKX equals to minus W by R into dALX. So if we take in the left hand side, we will get dAKX plus W by R into dALX equals to 0. So in this equation, this component will be equal to 0. So if we keep this equation in 3a. So similarly, least cost factor combination in sector Y will give dAKY plus W by R into dALY equals to 0. So in D3A, these two components will be equal to 0. Now, 3A can be rewritten as what we can write now? dPx by Py dW by R equals to ALY W into R ALY plus AKY whole square. Now here ALY into W by it will be ALX into W by R ALY plus AKY minus ALY into W by R ALX plus AKX. Now let's simplify this. ALY plus AKY whole square. So W by R ALY into ALX plus ALX AKY minus W by R ALX ALY minus ALY AKX. So here these two components will be, so here it will be minus, these two components will be diminished, and 3A can be written as ALX ky minus akx ALY all divided by W by R ALY plus AKY whole square. So what will be the value of dpx by py by dw by r? The denominator is a square term, so it will be always positive. So this is greater than 0. Now let's consider the numerator. Whenever you consider the numerator, just remember the condition of factor intensity at equation 1. In equation 1, what we see? ALX, ALY, AKY minus ALY, AKX greater than 0. So here the numerator is greater than 0 because of equation 1 says so. So from here we can say dpx by py dw by r is greater than 0. So px by py is positively directly related to the value of w by r. So now we use a diagram. In horizontal axis we represent w by r, in vertical axis we represent px by py. So this is the theta represent, the curve theta represents the relationship between w by r and px by py. Now from the factor intensity, factor abundance, we have already found that w by r in A is less than w by r in B. So let us plot the values here, w by r A and this is w by r B. So correspondingly we will see that this is the value of px by py in country A and this is the value of px by py in country B. So from here we can write that px by py A is less than px by py B. So we can write that A enjoys comparative advantage in X and B enjoys comparative advantage in Y. So A is what type of country? This is relatively labor abundant country. And X is what type of good? It is relatively labor intensive good. Similarly, so relatively labor abundant country enjoys comparative advantage in relatively labor intensive good. And this is a capital abundant country, relatively capital abundant country which enjoys relatively the comparative advantage in relatively capital intensive good. This is the proposition of Ohlin theorem. So here we prove that relatively labor abundant country will enjoy comparative advantage in relatively labor intensive good and vice versa. So H theorem is hereby proved.